Okay, I think it's okay.
Sir.
Yeah.
June 06, 24.
Oh, you have questions there? Hold on. Let me open up. It's right. Okay, you can see the question paper, right? Can
Yeah.
Okay, which question? June 06.
24. June 06.
June 06, Okay, June 06, 24. Okay, this question. This one, is it?
Yes.
Okay, this question. The others can give a try. Okay. So a displacement time graph shown in the particular wave. Second wave of similar type has twice the intensity. Intensity is twice than this, and half the frequency. And drawn the same axis, what would the second wave look like? Okay, the intensity is twice. Intensity twice, wavelength won't be double, right? Because here amplitude is 1 box. If amplitude is 2 box, the intensity is going to be how many times? 4 times, right? So what intensity is proportional to amplitude squared. Okay, this one like 1 box, so I proportional to I put 1 square, 1 square. So now they say intensity is twice. Intensity become double, so it's become 2I. Okay, proportional to the new amplitude which we are looking for. So we can find the new amplitude. The new amplitude 2 divided by 1. What do you get? 2 divided by 1. Equals, so it's going to be 2 here. It's going to be just x squared. So the x, the amplitude should be root 2. It's going to be root 2. So not even barely 2. It's going to be root 2. So yeah, A cannot be the answer because it's 2. 2 boxes means that the intensity should be 4I. It should be 4I. So A cannot be the answer. C also cannot be the answer because still 2 boxes. Okay. Yeah, so B and D could be the answer because it cannot be 2 boxes. It's root 2. Root 2, I think, is 1 point something, right? So B or D should be the answer. Okay, and half the frequency half, period double, right? So period here 2 boxes. So frequency half, period should be double. Now should be 4 boxes. So yeah, so the answer is B.
Sir.
Yeah.
Should we? I mean, why cannot we apply the formula like using intensity, amplitude, and also frequency together? Because last time I remember Sir said when we involve question with frequency.
Yeah, correct. So you in your mind, your formula is I proportional to amplitude squared, F squared.
Yeah.
Amplitude squared. But this is not in the syllabus, you know.
Oh, okay.
The in your syllabus is I proportional to amplitude square only in your syllabus. So although we know frequency is affecting the intensity, it is the research found. This is the actual formula. But in your syllabus, it's only I equals to A squared. When do you need to use this? You know, when do you need to use this I proportional to A squared F squared? If they introduce to you in the question, they say I proportional to A squared and F squared. They introduce you in the question, and then you can use it. As long as they never introduce in the question, they never introduce in this question, you have to follow your A-level syllabus intensity proportional to amplitude square. Okay, I think only once came out. I think in the 12 years, past 12 years, only once came out, which we have discussed that they include the frequency. But in the question itself, they say I proportional to A squared F squared. Then we have to follow this formula. Okay, if they never said this, then A level, you just follow this. R intensity is proportional to A square. You got an idea?
Yes, thank you, sir.
Okay, yeah.
Shouldn't when the intensity is twice, the amplitude would be like quadruple.
Yeah, like not even 2, so it should be 1 point something. Yeah. Root
So,
of 2.
but according to like the answers, the lines are not like only two maximum.
2 is the maximum, but 2 is intensity 4, right?
Oh yeah. Oh
Intensity 4, right?
yeah.
So which is the best option could be? Either B or D only.
Okay.
The best option. Best option. Yeah. So yes, in the PowerPoint, I put intensity is A squared, F squared, but when I explaining the PowerPoint, I told you that the F is not in your syllabus, only proportional to A squared. But why I put in the PowerPoint, because there is one passe came out with frequency, but they mentioned in the formula, the I proportional to A squared, F squared. If they mention, then you have to follow that formula. As long as they never mention, then I proportional to A squared. Any other question?
Sir,
Yeah.
page 27.
Page 27.
Question 24.
Question 24.
Yes.
24, all these are phase difference. Okay. Page 27. Page 27, question 24. Okay, the others who haven't tried, give a try. Two light waves of same frequency are represented by the diagram. What could be the phase difference between the two waves? So this is phase difference. So, yeah. Phase difference, you must choose two identical points. You can go for crest to crest, or you can use these 2 points too. These 2 points. These 2 points also is a phase difference. This also phase difference. The two identical points. This also phase difference. Same two identical points. So in this case, the phase difference is found to be 100 degrees. Okay. So it's very clear because I told you the x-axis can be x, can be time, sometimes can be angle and degrees. So if it's in terms of x, you have to, the phase difference is what formula you have to use, x over lambda times 2 pi. Okay, if it's time, as I told you, should be t over period times 2 pi. But if it's an angle, the phase difference, just that angle, just the angle. Or you want to convert to radian, just convert it to radian. Because phase difference can be in radian, can be in degrees, preferably in radian. Can be in degrees too, but here looks like they give in degrees. So the phase difference is 100 degrees. But as I told you last time, you know the circle, the particle, when the time zero, when the time zero, when the time zero, when the t is zero, when the time zero, the first wave, this is the first wave, this is your second wave, this is your second wave. The first wave is at origin. So the first wave is here, the first particle is here. Okay, the first wave. And the second wave is found to be somewhere here, somewhere here. Sorry, this, yeah, somewhere here, because at the lowest. So the phase difference, sorry, somewhere. Yeah, sorry, we can't draw this. Sorry, the phase difference is 100. But I told you, right? If the two wave, sorry, if the two particles and two particles has a phase difference 100 means they are separated by 100. Or what is the phase difference could be? The other angle also could be the phase difference. So phase difference could be 100, or the other one is what? 360 minus 100 also is a phase difference. So 260 is a phase difference. So therefore here we are looking for 100, but option don't have 100. 100 is the answer, but we don't have. So another option is 360 minus 100. So 260 is your phase difference. So you got it? So phase difference is whatever you got, theta. Another phase difference could be is 360 minus theta. Also can be the phase difference. In the circle can be the small angle, or the big angle also is a phase difference. Can you get the point? Any problem here? Can I?
Yeah.
Okay. Any other question? So If you don't have questions, we can go to the new topic. Any questions?
No?
No, okay, then, class. So wave is basic for the topic we're going to do now. Okay, this is the challenging one. Okay, so we move on to the new topic. So go to the PowerPoint. Okay, so this is the new topic. So everyone can see the PowerPoint. Okay, so today's lesson is topic 9, superposition. Okay. This topic, what you're going to learn is we're going to learn when two waves, when they propagating, when they meet, superpose. We call superpose. Practical name is meets. What are the phenomena can happen? When two waves meets, what are the phenomena can happen? It can do interference, of course. Interference happens. Interference happens and results to some sort of a pattern. Okay. So that's what we're going to discuss here. Interference can happen when two waves meets up. Stationary wave can happen, something new. Today's lesson is about stationary wave. Stationary wave or standing wave is opposite of progressive wave. Happens due to superposition of two waves. Okay. And yeah, so we're going to talk about phenomena when two waves superpose. Okay. So hold on, okay. Sorry, class. Let me check. Did I recording here?
Record.
Record. Okay, good. Okay, you see this diagram? First, you need to understand what is meant by principle of superposition. I believe you learned this in O levels. O levels, you learn about principle of superposition. SPM, I think you learn about principle of superposition. Okay, what is principle of superposition? When two similar waves arriving at a point at the same time, they will overlap. This causes resultant displacement at the point to change. Let's say these two waves, they meeting at one single point. Okay, like a water wave. Water wave, one is traveling here, another one is traveling, and they meet up. Sorry, when they meet up, superposition happens. The amplitude going to increase and decrease. Okay, you see, when this crest and crest meets up, the resultant amplitude going to increase. When the crest and true meet up, the resultant becomes zero. Okay, the resultant becomes zero. So when two similar wave arriving at the same time, similar wave have to be similar wave, not light wave and water wave can interfere, right? Both wave must be similar type, and they will overlap. Okay. Okay. The principle of superposition says that when two wave, similar wave, same type, meets at the same point, superposition happens. Okay. Okay, so this is principle of superposition. You have to remember 2 marks question. They will ask what is meant by principle of superposition. Okay, principle of superposition states that when two similar wave meets, when you say the word meet, 1 mark, you must say meet at a point. The resultant displacement is the sum of the displacement. This is another 1 mark of the individual wave at that point. Okay, this is principle of superposition. Okay, you have a point, one wave with crest of A meeting with another wave which is also crest with 2A, and meeting with another wave which is true with let's say half A. Okay, half A meeting this point. So according to principle of superposition, what is the resultant amplitude? 2A plus A plus minus half, minus half A. Okay. Okay, so this is going to be how much? It's going to be 2.5 A. It's going to be 2.5 A. So this is principle of superposition. So crest considered as a positive displacement, 2 we consider as a negative displacement. Okay. So as I told you, what is state of principle of superposition? When two or more wave meets a point, meets 1 mark, the resultant displacement is the sum of the individual displacement of the all wave meets at the point. Okay. What is the condition for superposition to happen? the wave emitting must be same type, must move in the same medium, yeah, and must meet. Okay, superposition. Okay, so one example. These are two separate waves moving meets, let's say. So determine the resultant displacement when time is 1 millisecond. At 1 millisecond, what is the resultant displacement? So what you have to do? At 1 milliseconds, here at 1 millisecond, check the displacement how much? Displacement is found to be about how much? About this value. So this is the value. So it's 3 box lower, negative 2.6 maybe. Okay, so negative 2.6. Negative 2.6. And this 1 second will be how much? 5. So it's about 3 box above. 3 box above, right? Yeah, 3 box above. So it's going to be like 1.6. 1.6. So when the time 1 second, the displacement should be 1.6 plus minus 2.6. Minus 2.6. So the resultant displacement will be what? Is negative 1. Negative 1 times 10 to the power of negative 4, because the power is negative 4 here. The negative 4 here, centimeter. Okay. So this is your resultant displacement. Just add them. If it's is true, then you take it as negative. If it's a crest, then you take it as positive. Okay, add them. Simply add them. So other points I don't want to do is the same technique. Check the displacement on the first wave, displacement on the second wave. At that time, add them. Okay. Okay, so that is principle of superposition. All the phenomena we're going to discuss is based on that superposition principle. Okay, so today's lesson is standing wave. Okay, what is standing wave? Standing wave, if I want to show, let me show a video. This is a standing wave, just temporarily. Okay. Sorry. Okay, so this is one video. You can see it's the standing wave.
So what we have here is a frequency generator. It's connected to what's called a wave driver. It's just a speaker. It's going to pump up and down at whatever frequency I set this guy to. When this guy pumps up and down, well, he sends a wave. Sends a wave down to this end, the wave reflects, comes back. Now, if I set it to just any old frequency, let me just turn this on. Well, now let's go a little higher. So it's sending waves back and forth, but these waves are out of sync, if you like. They're not exhibiting consistently constructive or destructive interference at any one point. But if I set it here, for example, I have what's called a standing wave. That is, the wave that's sent down and reflects constructively interferes with the next wave that comes down right at this point. Now the waves that come down and reflect, destructively interfere with the incoming waves right here. And that's called a node. I can touch it and it still is working. So the node is not moving. Here it's moving up and down, and here it's moving up and down. And we'll see that in a second with the high-speed camera. So here we have what's called the second harmonic. It's the second possibility for a standing wave for a string that's held at both ends. Because notice this is a node, and the middle is a node. So we have 3 nodes for this wave. Now, like I said, second harmonic, well, what's the first one? The first one will be half this number, so 8.5. And there we go. It's basically the scenario of a jump. Now, I can find any of the other, all of the other harmonics are multiples of this number. So we just saw that 2 times this number was the second harmonic, or the second possibility. Well, if I go 3 times this number, I should get the third harmonic. Well, 3 times 8.5, I guess that was around 25.5. And there we go. So that's the third harmonic. How many wavelengths is this? Well, it's 1 and a half. 1 and 1/2 wavelengths. And it's easier to see in high speed. So check out this shot with the high speed camera and verify for yourself that it is 1 and 1/2 wavelengths.
Okay, class. So this is the introduction. I just want you to see how the stationary wave looks like. Yeah, go back to the slide first. We will be continuing with the video later. Okay. So what is standing waves? Okay, what is standing waves? How it was formed? Standing wave happens when 2 similar waves with same speed. What is that? Two identical waves. 2 identical. I missed a very important word here. Okay, 2 identical, 2 similar. What you can say is a progressive wave. 2 similar progressive wave. 2 similar progressive waves with same speed. Okay, amplitude frequency. That's 1 mark lah. Similar progressive wave, you get 1 mark. Moving exactly in opposite direction meets, this is 1 mark, meets again 1 mark. At a point, they produce a stationary wave. Okay, so 2 identical progressive waves travel in opposite direction, meets, forms stationary wave, or called standing waves. Okay, all musical instrument, when you pluck the string up and let it go, when you, let's say you plug the string up, just now you see the video, when you plug the string up, there is 1 wave moving to the right, and when you come to the second junction, it reflected, and superposition happens to the incident wave and the reflected waves form a standing wave. The incident wave and the reflected wave is considered 2 identical progressive waves. They are identical. Their amplitude same, their frequency same, their period same, everything same. The only thing different is they travel in opposite direction. If they travel in opposite direction superposed, it can form stationary wave at particular frequency, not always, only at a particular frequency. Okay, for example, so this is the first wave. You shake the spring up and down, so you produce an incident wave. It's a fixed end. Then what happened? The fixed end, it bounces back, produces a reflected wave. So let's say you are continuously moving up and down. That means you're constantly moving in you are producing incident wave and reflected waves. This incident wave and reflected wave, when they superpose, these pulses are reflected back, traveling along the same line, equal speed, frequency, and amplitude, opposite direction. When they superpose, they produces a stationary wave like this. This is called stationary wave. Okay, how to see the stationary wave? Stationary wave and progressive, what is the difference? Progressive wave, the wave front will move forward. Okay, what I mean by wave front? The wave, right? The wave like this. Okay, the wave, after a short while, the wave front will move forward. Okay, it will move forward like this. Okay, so the peak, we can see the peak, the crest is moving forward. Okay, this is progressive wave. This is your progressive wave. But for the case of stationary wave, the peak, the crest will be just at that point. Okay, it never move forward. That's called stationary wave. You saw the video. There is a 2 loops forms. There is a 2 loops form. Do you see the crest is moving forward? It does not move forward. It just stays there. It's just oscillating there. The wave front, this is called wave front. The wave front does not advance, does not move forward. That's called stationary wave. Okay, progressive wave, the wave will move forward. The wave front, this is called wave front. The pattern is called wave front. Okay, the wave front will move forward. Okay, will move forward. That's progressive wave. That's the main differences. Okay, So, okay, so now the incident wave and reflected wave interfere to produce a wave pattern where the nodes, there is the nodes and antinodes happens here. I believe last time in your Form 5 O levels, you heard of nodes. What is nodes? Nodes is a point where constructive or destructive interference happen. Nodes is a point where destructive interference happen. Destruct means cancellation happen, so it forms a node. In this appearance, where's the node happen? The node happen at this age. So this is the node. This is your node. Okay. At this age also, it's going to be a node. When there is an oscillator, this is going to be an antinode. The center is antinode. It's antinode. So the two incident waves reflected to produce a wave pattern where the nodes and antinodes appears to be a stationary wave. So you have nodes and antinodes decorate the stationary wave. Stationary wave full of nodes and antinodes. No such thing nodes and antinodes for progressive wave. Progressive wave, no such thing as nodes. If there is a nodes means, just now you saw the video, he just trying to use his finger to touch here, it does not vibrate, he can hold it. Because the particle here at the node does not oscillate up and down because perfect cancellation happens. Okay, so this is called stationary wave. Okay, so these are the types of incident waves happens. Okay, before I go to this, before I explain this slide, let me show this first. Okay, this is better. Then I go back to that slide. This is what happens in the stationary wave. Okay, just now you saw the in the video. Okay, what you observe is this wave. You observe this wave. This is the wave you observe on the string. It forms a stationary wave. It's a form of stationary wave. You see the crest. This is a multiple loop one. This is multiple loop. The one showed in the video is only 2 loop. This one I think how many loop? 1, 2, 3, and you have this 4, this 5, and you have about 6 loops appearance. And this is a lot. The one showed in the video I think it's only 2 loop. Only got 2 loop. Okay, 2 loop. This is 6 loops. But anyway, this is stationary wave. But according to theory, they say what causes the stationary waves? At the background, they say there are 2 waves are traveling. The first one, this is your incident wave. This is your incident wave. And incident wave started by the oscillator. And the side got an oscillating it produces a incident wave forward. Incident wave forward. Then at the end here, reflection happened. So reflected wave moved to the left. So the incident wave and reflected wave superposed at the background. Final appearance forms like this, the stationary wave. Okay, you can't deny that at the background there is a 2 wave are traveling. Okay, so you need to understand there is a 2 wave responsible for the formation of stationary wave. Okay, so this is stationary wave. So how stationary wave is formed? Just recall back how stationary waves form. Stationary waves form when 2 identical wave, the top one, the 2 identical wave, 2 identical progressive wave, 2 identical progressive wave travel in opposite direction, superpose, produces a series of nodes and antinodes, results to a stationary wave. A stationary wave. Stationary wave is opposite to progressive wave. The main difference is what? Progressive wave, the wave front is in advance. It can move forward. Okay. In other words, in terms of energy, progressive wave, the energy is transferred from one point to another. For the case of stationary wave, the wave front does not advance. Or in other words, the energy is localized. That means we say energy is not transferred from one point to another. Okay, so that's stationary wave. Okay. Okay, so this is our stationary wave. Incident wave is acted, then reflected wave happen. Reflected wave going to the left. So finally, incident wave, reflected wave produces a stationary wave. So you have a stationary wave. So this is stationary wave, but make sure. But you must understand as a science student, at the background, incident wave and reflected waves are just moving at the background to produce the final appearance, the stationary wave. Okay, so this is the stationary wave. The wave front does not in advance. You see the crest is always there. It does not move forward. The wave front does not advance, or we can say the energy is not advanced. Okay, same thing happens here. This is completely tight. This is loosened. but both can produce as a stationary wave. Produce a stationary wave. Okay. Okay, so formation of stationary wave only occurs as at a certain frequency, only at a certain frequency, not any frequency. Don't simply say you set up a wave with the 50 hertz, the incident waves happen and reflected waves happen. Don't think you will get a stationary wave. Stationary wave only happens at a particular frequency only. So you have to keep on adjusting the frequency until the stationary wave occurs. Just when you saw the video, you just keep on rising the frequency. Only a particular frequency you saw the loop. Okay. So please, important, stationary wave only occurs at certain frequencies only. Okay, certain frequencies only. When the frequency is changed, the wavelength of stationary wave changes. The wavelength of the stationary wave changes. And of course, when the frequency changed, when you change the frequency, the wavelength gets shorter or longer. B equals to F lambda. When you rise the frequency, what happened to the wavelength? Wavelength will get shorter because the speed is constant. Speed is constant for the rope also. So wavelength will get shorter. When wavelength gets shorter, you will get, last time you get one loop for stationary wave. Now you can get two loops. You can get two loops. You can get three loops. You can get more loops because the wavelength gets shorter. This one wavelength, this one wavelength. Two loops makes one wavelength. Okay. So when you rise, when the frequency is changed or rise, the wavelength stationary wave also change now. When frequency rise, wavelength gets shorter. When wavelength gets shorter, what is the consequence in appearance? More loops will form. Okay. Just now you saw the video, two loops become three loops. What it done? You rise the frequency. You rise the frequency, make the wavelength shorter, more loops can be formed. More loops can be formed. Okay. So when two similar waves moving in opposite direction with same frequency, speed, and amplitude superpose to form a nodes and antinodes. Okay, so this is stationary waves. Okay, so yeah, stationary waves can form in three situations. Stationary wave can form in a pipes, in a sound, in pipes. Let's say you have a pipe. If you have a closed end pipe. Okay, closed end pipe. You have a pipe which one end is closed. Okay, and you blow. Okay, let's say you blow at the opening. You creating a sound wave. The sound wave will be reflected. At one particular frequency. You are lucky if you increase the pitch of your sound. At one frequency, you suddenly will listen a loud sound. A loud sound will happen. Okay, when there is a loud sound happen, we say stationary wave is already formed inside. So stationary wave can happen in a closed end, one closed end, one open end, two open end pipe. Two closed ends not in our syllabus. We only do these two. Two open ends and one closed end pipes. Okay, and stationary wave also happens in a string. In a string. Stationary waves happens as shown in the video. Is use a string to form a stationary wave. Okay, and they found stationary waves also happens in the water. Okay, in the water. Okay, let me show you that. In the water also stationary waves is found. Okay, so string, water, and sound. We have stationary waves, and they also found stationary wave in microwave. Microwaves also can form a stationary wave. Okay, we will be discussing this later. First, let's try to understand the sound, string, and water first. Okay, so a small recap. This is something new. So what you learned so far? So how stationary wave is formed? When two identical progressive waves travel in opposite direction, superpose produces a series of node and antinode, results to a stationary wave. Okay, how stationary wave different from progressive wave? Stationary wave, the wavefront does not advance. Or in other words, the energy of stationary wave does not move from one point to another. Progressive wave, the wavefront will advance, the energy will be transferred from one point to another. Okay, progressive wave, just a one wave, progressive wave, just moving forward. But stationary wave is actually made of two progressive waves traveling in opposite direction, produces a stationary wave. Okay. For progressive wave, superposition does not involve. For stationary wave, superposition is involved. So two waves need to be superposed to form a stationary wave. Okay. Any questions so far? Okay.
Sure.
Yeah.
Stationary wave only occurs by transverse wave, or longitudinal wave also can produce stationary wave.
Yeah, both can. Sound waves are longitudinal, microwaves are transverse wave. So both can.
Okay, thank you, teacher.
Okay. Okay, but the two wave, the condition is the two wave must be identical. Identical in terms of what? Identical in terms of everything. They must be same frequency, same period, but they must have the same amplitude. Then only stationary wave can form at a particular frequency. At a particular frequency. Okay. Okay, let me try to explain everything. Then you will have a clear picture. Okay. Let me go back to the video again, just to understand. Okay, so let me go for a full swing again. You see. So this is three loops, these three loops.
So again, third harmonic, 1.5 wavelengths. Well, let's go to the sixth harmonic. The sixth harmonic will just be double this frequency. So we go up to 50. And there we go. That's the sixth harmonic. Beautiful. And it's 6 times the fundamental frequency, which we measured in the beginning to be 8.5 hertz. So check this guy out. We have 1, 2, 3 wavelengths. And in the next video, the explanation video, we'll go through the calculations and the derivations.
Okay, pass. Okay, let me this is another one. Okay, let me show stationary waves happens in the water. Okay, this is one wave. This is a good one. Okay, this is scientists try to find stationary wave by using water. You see this video? Here you see the ripple, it will form a stationary wave. The incident and reflected going to form a stationary wave. The incident wave is happening. You see the crest only happens at the same point. You see the crest, I'm touching with the cursor. The crest is just there. You never move forward. And this is your stationary wave. Crest is always there. Never move forward. And this is the stationary wave in the water. How it happens? You see the crest? Crest is just happen at the same point. So this is a stationary wave. Okay. Yes. So that's the stationary wave. So the first thing we're going to talk about is the stationary wave happens in the sound. Okay. First we could talk about the stationary wave happens in a string. Okay, this is the setup we're going to use to form a stationary wave. When we manage to get into the lab, maybe later, hopefully. Okay, this is the setup we're going to do. We're going to have a frequency generator. Frequency generator is the device. Just now you saw the video, the guy is adjusting the frequency. He actually adjusting the frequency at the frequency generator. Frequency generator is a device can change two things of the oscillation. Frequency generator determines the frequency of the oscillation of the oscillator or the vibrator, and it determines also the amplitude of the vibrator. Okay, the frequency generator determines two things: frequency and the amplitude. Okay, so you adjust your frequency. This oscillator going to oscillate with the same frequency, going to oscillate the string. So the string going to produce an incident and reflected wave, and it can form stationary at one particular frequency. So these are the patterns it can form. Okay, the one loop pattern we call fundamental. We call special name and famous fundamental stationary wave, fundamental frequency. We call it one loop. Fundamental frequency means that is the lowest frequency a stationary wave can form. What is fundamental frequency? That's the lowest frequency a stationary wave can form, the lowest frequency. And when you go for fundamental frequency, the number of loops will be limited. The lowest, I mean one loop is fundamental frequency. Okay. So in this fundamental frequency, you have two nodes. The edge will be two nodes. The center will call anthenode. Okay. So when you rise the frequency, let's say the first appearance fundamental, let's say happen at 50 hertz. Okay, you rise the frequency from 50 hertz to normally double. 50 become 100. Normally for the string, you will get two loop. So the first one, let's say, happens in let's say this happens in 50 hertz means, okay, 50 hertz. This will happen in 100 hertz. This will happen in 150 hertz. We'll be learning this, why this like double and triple causes this stationary waves. The next class we will be discussing this. Okay, now, so if E put 50 hertz, you got a first loop, and if he put 51 hertz, you won't see any loop. You can't see the stationary wave anymore, 51 hertz. You only can see the clear second loop happens at 100 hertz. So the stationary wave only happens at one particular frequency, 50 hertz, 100 hertz, and 150 hertz. Okay. Okay. So we hang a weight here so that the tension of the string can be adjusted. Okay. This is a little out of syllabus. Okay. I show you this. The speed of the wave in the string. The speed of the wave in the string is determined. This is the formula. This is out of syllabus, but good to know. Okay, the speed of the wave in the string, how fast the wave traveling, is depend to two factors: the tension. Okay, the tension and the mass per unit length. The mu is actually mass per unit length of the wire. The mass per unit length. How heavy is the wire per unit length? How thick is the wire line? In other words, we determine the speed. Okay, so you put more tension, that means you add more weight here. It's going to result to the speed of wave become even higher, more faster. You know the guitar. So I don't know how many of you play guitar. Like in the guitar, the string, right? Every string will have a different thickness. Have you seen that? Every string will have a different thickness. Okay. And at the edge here, you can turn the string so that for what? You can change the tension. If you change the tension, what will happen to the string? The speed of the sound will increase. The speed of the sound will increase when you increase the tension of the string. And speed of the sound is different at every different, string. Because of what? Thickness plays a role. More thicker it is, the speed of sound is lower. Okay. So what to do with the speed? B equals to F lambda 1. Speed of sound going to affect the frequency of the sound produces. So the guitar, when you play the guitar, I think the thinner, the high tension and thinner wire, the lower mass per unit length, will result to the greatest speed of sound. Therefore, you're going to result to the greatest frequency of the sound produced. You listen. Okay. Okay. So in other words, speed of sound in the string is determined by what factor? The tension and the mass per unit length of the wire. So in this case, we keep the tension as constant. We make the tension and constant so that we want the speed and in this wire become always constant. Okay. So this formula is out of the syllabus. They never tell you, but good to know that tension and mass per unit length affects the speed. Speed affects the frequency of the sound. More higher the frequency, high pitch. Okay. So yeah. So you see this appearance here. How can you calculate the wavelength of this wave produced here? You can calculate. What is the lambda of each mode? Okay, the first one, the fundamental. This is how many lambda? This is how many lambda? The first one. First one is from node from here to here is considered like, if you add another one, this is one complete wavelength, you know. So from here to here is how many lambda? From here to here is considered half lambda. It's half lambda. Okay. For the second one, from here to here, how many lambda? This is one loop up to one loop another down. So this is like one wavelength. So this is one wavelength, one lambda. Two loops makes one lambda. One loop is half lambda. Okay. This is how many lambda? From here to here. This is 1.5 lambda. Okay, 1.5 lambda. Okay. So yeah, when frequencies get higher, V equals to F lambda. We fix the speed already. We fix the speed. How we fix the speed? We use the same string. We use the same tension law. So we fix the speed. So if frequencies rise, you see 50 become 100, 150. Frequency rise, the wavelength will get short. So wavelength get shorter. Wavelength get shorter, right? Because the length of the string is permanent. The length of the string is L, same length. Let's say the length of the string is 1 meter. It's 1 meter. So if the length of the string is 1 meter, for the first one loop, what is the wavelength will be? The half lambda will be equals to 1 meter. So then what is the wavelength of the first one loop will be? Is half lambda is 1 meter, so lambda will be 2 meter. So the first appearance, the lambda is 2 meter. So the one loop is 2 meter. So we can find the wavelength. The information they must give you is, the information they must give you is the length of the string, From the length of the string, you can find the wavelength. Okay, now tell me, for the second appearance, what is the wavelength value? The 1 lambda equals to the length of the string. So in this case, I just give a value 1 meter. So in this case, for the second appearance, lambda is exactly 1 meter. It's 1 meter. The first one, one loop, the lambda is what? The first one, one loop, the lambda is 2 meter. So first loop, the first appearance, the second appearance, the lambda getting shorter or longer? 2 meter become 1 meter. What? So lambda gets shorter, and lambda is getting shorter. Why getting shorter? Because frequency has been raised. Obviously, speed is constant. Okay. So the third one, can you find what is the wavelength of the third one? Third appearance, 3 loops. So 1.5 lambda will be same as the length of the string, which is 1 meter. So the lambda will be how much? 1 divided by 1.5 lah. So you get, I think you get 0.67 meter. That's your wavelength. Wavelength get even shorter. Wavelength get shorter. So when you rise the frequency, the wavelength gets shorter. And you get more loops. Okay. Any questions so far?
I have a question.
Yeah.
So, do we call it a fundamental or an overtone or a harmonic?
Okay. Don't get confused with the overtone first. The famous one is the fundamental frequency. Fundamental frequency means only given name for the first appearance only. First appearance we call fundamental appearance, so we can say fundamental frequency. The second and the third, we never use the term fundamental. Okay.
So what is the difference between overtone and harmonic?
Okay. Okay. First overtone means. Okay, I go for harmonic first. Harmonic means this is first harmonic. The first one is called first harmonic. First harmonic means always the fundamental is the first harmonic. Okay, first harmonic. The original frequency 50 hertz. Okay. The following pattern, let's say it happens at 100 hertz. In this case, it happens at 100 hertz. 100 hertz, how many times greater than the fundamental frequency? Twice, right?
Yes.
Then we call it second harmonic. Okay. So the third one, how many times greater? Third frequency, how many times greater than the fundamental frequency? So we call third harmonic. Okay. So what is meant by harmonic means? Let's say I say there is seventh harmonic. Okay. So there is a stationary wave with seventh harmonic. So what you should understand, the frequency of this seventh harmonic is 7 times greater than the fundamental frequency. That's harmonic.
All right.
Okay.
Yes.
The term overtone, you just ignore. I think not in A levels. Harmonic is important. Okay. Okay. Any other questions? Okay. So this is a setup. This is how it should look like. Okay. So you learn something a lot, new stuff. Okay. So I don't want to add more. After 1 hour, we will continue with the 12 to 1. 12 to 1, we have a continuation of this topic. Okay. So for time being, today's lesson, what do you learn? You learn about superposition. What is meant by superposition? When two wave meets, superposition happens. What is principle of superposition say? When two identical wave, two similar wave meets, the resultant displacement is the sum of all the displacement of the wave individually at that point. Okay, then stationary wave. 3 marks. How stationary wave is formed? When two identical progressive wave, you must say two identical progressive wave travel in opposite direction, superpose, results to a node and antinode, results a series of node and antinode, produces a stationary wave. Okay, what is the stationary wave different than progressive wave? Stationary wave, the wavefront does not advance. Progressive wave, the wavefront advance. In other words, progressive wave, energy is transferred. Stationary wave, energy is localized, does not transfer. Okay. So, okay, so I think lots of new information. I stop here. If you have any questions, you can ask me. Okay, class. About the tutorial 2, I already sent the answers. I think one of you said there is a mistake. Let me check that. If there is a mistake is correct, then I change your marks. Change your marks. Go through your tutorial first. Tutorial 2. Maybe tomorrow, maybe the next lesson, you can bring up if you have any problem with the solution. If you still don't understand, we can discuss in the class. Maybe tomorrow after you go through the tutorial 2. Okay, any questions? Okay, so I stop here now. I see you 12 o'clock. Okay then.